Let's continue with the lecture part. I still have a chance to stay awake, at least a shot at it. But troubleshooting access control lists. That's one of those things that Epic EM, the Epic Enterprise module, can do for you with the path that we saw a little bit earlier. But the first thing to me before you start troubleshooting access control lists, check to be sure that whatever you're trying to limit works, or check to be sure that the process works before you apply the access control list. If it doesn't, it's not going to work after you apply the access control list. So determine whether there is an ACL problem. You need to remove the access list and test. So did it work before we applied the list? And this is an implication that we were trying to limit some traffic and let some traffic through, and that the traffic was supposed to get through couldn't get there. But did that work? Does that work before the ACL was applied? Test the interface on which it's applied in the direction of flow. I used to say, be the packet. Be the packet. You're a TCP packet with this port number and you come up against this access control list. Does it apply? You come up against the port. Is it applied in the correct direction? Is it applied in and out in the proper direction? To verify the access list first, it's important that you verify the direction and ensure that the sources and destinations are correct. So did we get the source and destination correct? Is it applied in the correct direction when we look at that thing? The interface is not on the path that the traffic is routed through, and that's the other thing. And the other implication is that we did a deny and traffic still getting through. Does the traffic go through the interface that we applied it to? Does it go where we think it does? So this goes back to checking your route tables too. Do a trace route, probably the easiest way to do that. Check the entries in the ACL, that the addresses and port numbers that you have been entered correctly, that you didn't make a typo. If I was looking at it, first thing I would look for was typos. The order of operations, the permit or deny. The order of operations is significant. The most specific should be at the top. Because if we do a permit the entire network, the 0.0.0.255 wildcard mask, and then the next statement is we deny host on the same network, it's never going to get here, because once it's permitted in the first statement, it'll never go to the second statement. Be sure that the order that you apply these things in are correct. And this again is be the packet. Go down to the access control list. Does this apply? Does this apply? Does this apply? Did the statement that I expected to affect that particular address in the port actually affect that address and port? Now there are a number of 15, 30, 40, 50, 60 an hour's worth of labs. And again, this is where tomorrow night you're going to get some. This is just a short kind of ending thing, VRRP. We started out tonight with HSRP, the Cisco proprietary first hop redundancy protocol is what it's called. The first hop being going out our gateway, the first hop that we're going to the internet on, so that if our primary router, our active router goes down, then we have a standby. And again, it really is kind of like in the NFL, the backup quarterbacks. Backup quarterbacks don't typically get a lot of work. They just sit there and wait for something bad to happen. If something bad happens, they go on the field and perform the duty for as long as the starting quarterback is down, hurt, whatever else. The routers do the same thing, and we manage control by priorities what happens to them. We designate by specifying a priority who's going to be the primary router, or in this case, we're going to have we have active and standby in HSRP. We have master and backup in VRRP. A couple of differences between the two. I said that HSRP can only have the active and the standby. In VRRP, we have the master, and then everything else is going to be a backup. So we can have multiple backups in VRRP. In HSRP, we had to enable preempt so that once the main router got fixed up and running, it would take control again. VRRP preempt is a default. So now with the slides, allows you to configure a group of routers that share a virtual IP address. Virtual IP address. I don't know how I did that. Provides for transparent failover of the first hop router. Okay, so we're going to have the virtual router backup, virtual router backup, virtual router master. In here, we're going to have the virtual router group IP address 10.10.0.1, 10.10.0.1 is going to be the default gateway of these things. It's an industry standard. HSRP is Cisco proprietary. Select a master router in the router group. We'll handle all the packets for the virtual IP address. And I kind of don't like the way that they did this. I like to kind of like have my little virtual router in here, and maybe 2, 3, and maybe this one's physical is 4, and this one up here is going to be 1, so that it is associated with this router until it goes down, and then it moves over to this router. If it goes down, it'll move over to this router, and on down until we run out of backups or standbys. Because in HSRP, we can only have one standby, but if the active router goes down, the standby router becomes the active router, we elect a new backup router, so we're always going to have a backup. The remaining routers will be on standby, will take over if the master router fails. And in the YouTube stuff, I've put in a how to configure a step-by-step configuration of HSRP. You can't configure VRRP in Packet Tracer. VRRP is the standard. HSRP is the Cisco proprietary that does the same thing. We have 2 devices, one running and one standby, one waiting. 2 methods to used by the LAN client to determine the router that will be the first hop default gateway. One is a dynamic process, some processing and configuration overhead, and it's the same thing that we talked about earlier, proxy ARP, routing protocol, ICMP route discovery protocol client. We're probably not going to see those things in our workstation. We're going to go in with a static configuration, and we're going to, even with DHCP, we're going to get an IP, a mask, gateway, and a DNS server. Are going to be the minimums that we're typically going to be assigned, either by going in and typing them in manually or getting them with DHCP. So it's going to be statically configured to a default router. The client simplifies the processing configuration as well as the load on resources. Single point of failure, and that's what HSRP and VRRP is all about, is preventing that single point of failure where we have our 2 routers and we have a virtual router, with the virtual router pink. The virtual router in the middle. The virtual router is the IP address of the gateway, and it's also going to be the MAC address that we use. Advantage, MAC address, having a single MAC address, we don't have to re-find the MAC address if anything changes, because If it didn't, we would have to go through the ARP process, wait for the timeout, and all those other things that have to happen to get the correct hardware address in it. So the failure of the default gateway, this one goes down, it's the active router. Then we fail over to the backup when we have a VRRP. Static configuration by enabling a group of routers or VRRP group and sharing a single virtual IP address that we can configure. Clients using a virtual IP address as their default gateway. It also has a MAC address, a virtual MAC address that goes along with the virtual IP address. I've got a chart in a minute that shows those things. So provides the following list of advantages. What do? Allows us to configure multiple routers. Configure multiple routers as a default gateway router. Such configuration will reduce the possibility of a single point of failure. Multiple routers, single IP. We have to have the single IP. If we didn't, then we're going to have some sort of the dynamic mechanism that if one goes down and says, "Oh, I've got to go find a new gateway," so I'll find that gateway. Load sharing allows us to share the traffic from the LAN clients among the routers. It ensures that you can equally distribute the load among the available routers. Multiple virtual routers. Support up to 255 virtual routers for VRRP groups. On a router physical interface, lots of virtual routers can be configured here. Implementation of redundancy and load sharing in our topology. Multiple IP addresses. Manage multiple IP addresses, including secondary IP addresses. Secondary IP addresses are not primary, obviously. They're secondary addresses on an interface. So we can have more than one address on an interface in a router. We'll be able to configure it on each subnet, VRRP on each subnet, when we have multiple subnets on an Ethernet interface. So we can use it on VLANs, and in order to have redundancy and also to share the loading. Preemption, to substitute a virtual router you deployed previously to overcome a failing master router. Oh yeah, those are fancy words. With a different virtual backup router. Usually the newly selected will be higher priority, which may have been previously unavailable but now has become available. Preemption, we do the priorities. 100 is the default. If we assign a priority of 120, it's going to become the active or the master router. If it goes down, the next highest priority device will assume the duties. If this was the highest priority when we fixed it, since in VRRP preempt is enabled by default, it would resume the duties as the primary router, so that it would then be the one carrying the load. The others would then be waiting for them to fail in case they're actually needed. Authentication uses MD5 digest to protect against VRRP, to protect against VRRP spoofing. Uses an industry standard MD5 algorithm. Dedicated IANA standard multicast. It's the 18 address. It's also going to have, and they don't put it in here, but the numbers that you kind of want to be familiar with, the MAC addresses. It's on a, it's going to be on one here in a minute after we go through the lab stuff. Identify the packets on the second. Now, IANA has assigned the IP protocol number 112 to VRRP. Object tracking. I was a virtual master, ensured that VRRP priorities tracked objects such as the interface, and we talked about object tracking. Track, if we had these things and our information was going here, the only thing it's looking at, if this interface goes down, this one will change. But if this interface goes down, it doesn't report, and that's what object tracking is. That if the outgoing interface goes down, we decrement the priority down here so that this device gives up its primary duties and shifts them over here. So that's what tracking, interface tracking is about. 15-30 minutes worth of labs. This is a couple of things to look at here. And what I want to point out is the virtual MAC address. And then when we did the HSRP, it had the 0000C, which is going to be Cisco. And then we had 07AC. The XX is going to be the group, the HSRP group number. Same thing over here, except we have 5E00 instead of 0C07 and then 01. This is going to be the group again. And GLBP, which is beyond the scope of this, is Gateway Load Balancing Protocol. Each of these we have to kind of do a manual load balancing by doing half of our IP addresses with one gateway and half of our IP addresses with another gateway. And then they will go to whichever of their devices is active. Because we're using the virtual addresses as the IPs. Some other things in here: preempt if a router has a higher priority than the active router, and preemption is configured. And here preemption is configured. We have to go in to that HSRP group number and give it the preempt command. And again, as you have seen, it's not that big a deal. Standby is the command. Standby is the command that you should remember. Show standby will show you the status of the interfaces, which is taking the load and which is sitting and waiting. It will take over as the active router using a coup message, and then the one that's being cooed sends a resign message. And by default, VRRP are configured for preempt. Gateway allows a router to preempt and become the AVG is active virtual gateway if it's a higher priority than the current active virtual gateway. Numerically higher priority wins on these, and this one balances automatically based on configurations. Tracking, the HSRP algorithm decreases the priority by 10 when the tracked interface goes down. VRRP really doesn't have a tracking option. AVG assigns the necessary virtual MAC address to each of the routers participating in the group, and up to 4 virtual MAC addresses can be used by any group, which is going to give us some of that other capability. So the summary slide here: HSRP, useful for hosts that do not support discovery protocols such as IDRP, which is do not like everything. We'll say most. Can't make this one work. This is why I don't use it. We'll say that would be most of those. Assigning a priority to the routers allow you to select the active and standby. Active and standby is HSRP. HSRP preemption feature with enables the router to immediately become the active router. If the original router goes down, preempt must be configured. I can spell it right there. We have to configure it with the preempt command. Private cloud creates a service within a company. IT Foundation acts as the basis for virtual services, and then the IPv4 access control list and IPv6 access control lists used to provide basic network security. The APIC EM is Cisco's software-defined network controller, and we're going to talk about software-defined networks for enterprise networks. And in it, we had the ACL, checks the ACL in the path to see if it's affecting anything. VRRP group routers to share virtual IP address just like HSRP did, but it's the standard, whereas HSRP up here is a Cisco proprietary. Will allow you to solve the static configuration problem by enabling a group of routers that will share a single virtual IP address. So HSRP and VRRP do the same thing. Cisco proprietary, and then the IEEE standard here. So with that takes care of the lecture part.